Question 9.4. Find the moment of inertia of a uniform cylinder about an axis through its center of mass and perpendicular to its base. Mass of the cylinder is m and radius is r. So you are having a cylinder here. Mass of whole cylinder is m and radius of cylinder is r, capital R, and you will have to find the moment of inertia of a uniform cylinder about an axis through its center of mass and perpendicular. This is the base, so perpendicular to its base. About this geometric axis, you need to find out the moment of inertia for this cylinder. For that, we need to calculate its moment of inertia by the formula of rigid body. Do you remember the formula for moment of inertia of rigid body? That is equal to r square dm. And here, because we are talking about a 3D shape, so we need volume density, which is rho, that is equal to mass by volume. By this formula, we will calculate dm is equal to rho dv. So here we can write r square dm is equal to rho dv. Okay, now for the formula of rho, we need to, for the formula of dv, we need to calculate, divide this whole cylinder into small spherical disc. Now the formula of dv becomes volume of shell, which is equal to 2 pi rl. What is this 2 pi rl? This is curved surface area of cylinder. Volume is area multiply height, so height is dr. This difference, we will take the shell with the radius r, and the small disc around this r is of radius dr. So we will multiply this area with this width thickness 2 pi rl dr. Then I becomes equal to r square rho 2 pi rl dr. Okay, now move these values out, 2 pi rho l, and inside it becomes r dr. We will integrate this up to 0 to r, as r is the final radius. 2 pi rho l r4 by 4, 0 to r. Then this becomes equal to 2 pi rho l r4 by 4 minus 0. This is equal to 2 pi rho l r4 by 4. Now the value of rho, we will displace the value of rho again, that is equal to full mass by full volume also, and the full volume is pi r square l, volume of cylinder. By placing this value, it becomes m by pi r square l into l r4 by 4. Then l, say l r4 r2 2 pi, and this is equal to, it becomes equal to 1 by 2 m r square. Actually, by default, you will have to learn this fact that the cylinder's moment of inertia about an axis perpendicular to the base is 1 by 2 m r square. Okay, here is the table which you need to learn, and see, here is the cylinder about its own axis, and solid cylinder we are talking about here. So about its own axis perpendicular to its base, moment of inertia is 1 by 2 m r square. So you don't need to calculate, you can also memorize this fact and directly take your answer. Now for next topic, example 9.5, we need to learn this formula, radius of gyration. What is this? This is perpendicular distance of a point from the axis at which the whole mass of body could be concentrated without any change in moment of inertia of body about that axis. Okay, so a perpendicular distance of a point from the axis, here this is your rigid body and this is center of mass of that rigid body. So of a point perpendicular distance of this point, if this is the axis of rotation, then you need to calculate, this is the perpendicular distance and you need to calculate this radius of gyration k. Now this radius of gyration, by this formula I can be written as mk square, and k becomes equal to root 1 I upon m. This is the formula for radius of gyration. So for example number 9.5, a wheel of mass 8 kg has moment of inertia equals to 0.5 kg meter square. Calculate its radius of gyration. Such an easy question. You will have all the information here. Mass is 8 kg and moment of inertia is 0.5 kg meter square. Then radius of gyration denoted by k, having the formula I upon m, becomes equal to I 0.5 by 8. So by solving this we will get 0.25 meters our answer, or we can write it in 25 centimeter. Now 9.6 question. The moment of inertia of a solid cylinder about its axis of rotation is, you know that this is 1 by 2 mr square as talked in the example number 9.4. What is the value of radius of gyration of the cylinder about this axis? Okay, so here it is given as I is equal to mr square by 2, but I can also written as mk square. Then mk square becomes equal to mr square by 2. M से m cancel, then k becomes equal to root r square by 2, and this is r by root 2 for that solid cylinder. Okay.